Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 4B. Myself, Ishita Soran, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 8th World Conference on Smart Trends in System Security and Sustainability, WS4 2024, London, UK. The 8th edition of the conference is being organized in hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through from 24th and 26th of July 2024. I hope you will all enjoy the knowledgeable and interactive sessions through today. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we begin the session, I would like to introduce you all to the chair for this session. We have with us Dr. M. Shamim Kaiser, who is currently working as a professor at the Institute of Information Technology of Jahangirnagar University, Sawar, Dhaka, Bangladesh. He's an associate editor of the Cognitive Computation and IEEE Access Journal, guest editor of Brain Informatics Journal, IJACI and Cognitive Computation Journal. Dr. Kaiser is a life member of Bangladesh Electronic Society and Bangladesh Physical Society. We welcome you, sir. I'd also like to invite our next chair, who we have with us, Dr. Meenakshi Memoria. She completed her research on fault tolerance in grid computing. She has 17 plus years of teaching experience in different academic institutes. Presently, she's an assistant professor in College of Computer Science, King Khalid University, Aba, Saudi Arabia, and her research and teaching interests include machine learning, grid computing, theory of computation, compiler design, operating system, intelligent system, data structure, etc. We welcome you, ma'am. We'll be beginning with our paper presentations. I'd like to invite a first paper presenter, Gurdal, with the paper titled Application of Data Analytics for the Benchmarking of Content Genres at Video on Demand Streaming Platforms. You may start with your presentation, sir.
Yes, can you see it?
Yes, sir, it is visible. Please go ahead.
All right. Yeah, thank you for the introduction, and everybody welcome to this session. My name is Dr. Gürdal Ertek, and this is our joint work with Dr. Anant Shirawari and two of our undergraduate students, actually. This was part of their senior project, and we were able to work on it and obtain some really good results. And here we are with the paper. Okay, so this paper is about the application of data analytics for benchmarking. Benchmarking, as you know, it means comparison, comparing, understanding how different entities differ, how they are similar. Okay, so we are going to apply data analytics for this benchmarking. And the thing that we will be benchmarking is actually video on demand streaming platforms. So we know which ones they are. Here are the ones that are in our study: Netflix, Amazon Prime, HBO, Paramount, Disney, and Apple. And so basically we apply data analytics, and we apply things that have never been done before, neither on Kaggle or GitHub, and we understand some new things that were not in the literature, and that's our contribution basically. And what we will be comparing is the content genres, what type of content each platform has, and what are the associations between them. Okay, so this is the outline. We discuss the research topic, we motivate the research, and describe the methodology that we developed, describe the data, and explain the results, limitations, and conclusions. So the research topics is the data analytics methodology, development, and application. And the goal is to analyze and compare the genre of content on different video on demand platforms. Specifically, we analyze the distribution of genres across different platforms. Okay, so what about video streaming? It's actually become extremely popular. I don't know you guys, but I have, I think, 3 or 4 different subscriptions myself, and They are really very, very convenient, and I'm preferring mostly over cinema most of the time. Of course, cinema has its own place. So there has been high growth rate in video on demand. And the reasons are mentioned as convenient navigability, interactivity, and recommendations engines. So how are these platforms selecting their content? What type of genres are they preferring? That's something that is certainly worth some interest and some study. But no studies were encountered that used association mining of content genres to benchmark multiple platforms. So association mining means which genres are appearing together, or if a certain genre, for example, if drama is observed, what is is also let's say, is that same show or same movie also comedy, drama and comedy? Probably not, right? But what about drama and action? Okay, so these are the rules, association rules, and the way we identify those rules is through association mining. So no study was done on the genres, content genres of these video on demand platforms. So this is our goal, to analyze the similarities, contrasts, and associations between different genres of movies across leading video on demand platforms. Okay, so we start with domain knowledge and the data itself, and then we developed our methodology, and now it's ready to be used by analysts and planners in the industry. And this is also a very nice approach, especially if there's a new project, a new platform that is being developed. They can really position themselves in the market and maybe try to target some profitable, of course, and large enough niche in the market segment. So this is what we are doing. Okay, and this is the methodology. This is the data analytics methodology that we developed. So the analysis begins with acquiring the data set, and that will be the raw data set, which will later on be turned into a different data set. But we merge different data sets from different platforms. We clean the data, and that one will be the source data set. Then we filter these genres and we obtain genre transactions dataset. So it's like every show or movie together with the genres that it has. It's like a market transaction, like when we apply market basket analysis. So now we can also apply association mining for that. Okay, so that was the data preparation stage. Oops, sorry. Data preparation stage. And then once that one is finished, we can begin the analysis. We run a priori. We obtain the association rules and metrics. We transform and prepare that data to obtain association rules dataset. And then we analyze these association rules through different means. Here are the methods that we employed: network visualization, heat map visualization, bar chart matrix, and scatter plot matrix. Again, I mean, these are all techniques that exist as data analytics or statistical or data analytics techniques, but then they were not used in this context in earlier literature. So now let's see how we did that. By the way, the source data was obtained from Kaggle, and the analysis was conducted by mainly using R programming language and its multiple different R packages. This is a list of all these different packages. A rules and A rules with, these are the two main R packages for association mining and the visualization of results. And all the source code and the data we posted under GitHub, which you can also scan from here from your telephone, and you could immediately access the GitHub repository. Of course, the link will also be in the paper as well. Okay, so the first result is basically comparing all these platforms. Support means what percentage of the show. So this means like 19% of the shows on Amazon are having action as genre. 0.5% only is animation. So you can see they are not the same. They are not all uniform. There are a lot of contrasts. Hence, the data set is very suitable for comparison. So since we are short of time, I will not go into the specific interpretations too much, but my goal is to show you the types of interpretations that could be made. So here's a real quick one. Amazon Prime does not produce many documentaries. It has low support value. Let's see that. Yeah, Amazon And when we look at the documentaries, well, it's written documentation, but that should be documentaries. It's really, really low compared to other platforms. Look at these other platforms. They have all higher. So if you want documentation, if you are the type of person who wants documentation, Amazon Prime is not your thing, okay? Maybe if you want documentation, you should be trying out this one, which is Disney and HBO and Apple. Okay, so they are better with documentation. So this is how you could do it. Again, oops, there you go. All right. I will not go through all the results. I just want to show you the types of things we did. So network visualization. In here, the nodes are the genres and genre combinations. So this way, when we map them on a graph, we can see which genres are appearing close to each other, like animation, family, comedy. They seem to be really close to each other. War and Western, they are close to each other. Action and drama, thriller and crime. So this is an overall map. Then we could also visualize the specific rules, if A then B type rules, as a heat map where the color shows the lift or other metric. And then we could do another bar chart matrix visualization, but this time not for the single genres, but for the rules themselves. So if war, then drama. If romance, then drama. If thriller, then drama. By the way, we sorted them with respect to the decreasing values of the average. So these are the decreasing values of the average confidence. So this is how we sorted them. And again, there could be many comparisons that could be made. And for example, something really interesting is animations. When it comes to animations, it's mostly families at Apple. But then when it comes to animations, it's mostly not, it's not as strong for family in HBO. So the animations we see at HBO, they are not necessarily family friendly. Okay, and this is our, I think, nicest analysis. So where we did a scatter plot and we were able to identify the outlier rules. This way we can really see what is different between these two platforms. So for example, if European then drama, if a European content in HBO here is more than twice as likely, which is because here it's 8, this is much less, okay? More than twice as likely to also be a drama compared to European content in Disney. So again, we can see how the association rules differ between the platforms. So of course there are some limitations, but then hopefully future research can address those. And this is me, by the way. This is my website. And you can find my other research over here. So my time is up, just 10 more seconds. We are from UAE University in United Arab Emirates. The castle that you see on the right, that's from our city, Al Ain, where we have our university. And the other photos are from United Arab Emirates. And this is my background. I got a PhD from Georgia Tech in industrial engineering, and I worked in Turkey. I work in USA. I'm an alumni of A-Star at Singapore. So if there's anybody from Singapore or had a Singapore experience, greetings. And these are my research areas. So would be very glad to connect. Just you can just connect to my website, and then you can find my contact information there. Okay, and I think it's also here on the very first slide as well. I think we also put that one over here as well. Okay, anyhow, so that's all from our side. Yeah, if you'd like to contact any one of us, that is me right here, and that is Dr. Anand, who's I think also in the room at this point. That's all for us. Thank you so much. Any questions?
Thank you, sir. Sir, ma'am, would you like to ask any question? It seems we have no question. Thank you, sir, for your presentation.
Thank you so much.
We'll be proceeding with the next presenter. I'd like to invite paper presenter Rafian Ramadhani with the paper titled Digital Transformation of MSMEs in Mutang Village, Implementing the RSM Utility Design for Enchanted Market Access and Operational Efficiency. So you may start with your presentation. Sir Rafian. If you're here, it seems we do not have him. We'll be proceeding with the next paper presenter, Mireya Tovar, with the paper titled Integration of Text Classification with Semantic Relationship, Embedding Models in Topic Discovery Aimed at Opinion Mining. Ma'am, if you're here, then you may start with your presentation. Ma'am Mireya? She's not here yet. The next paper presenter is Honorato Cali with the paper titled Modeling Simulation and Temperature Control in Rapid Cooling Tunnel. Sir, if you're here, then you may start with the presentation.
Okay, okay, thank you.
Thank you, sir.
My name, Honorato Calipaco. My paper modeling simulation and temperature control in rapid cooling tunnel. I'm from National University of Moquegua, Peru. Introduction, refrigerant storage of fruits and vegetables with slow microbial growth. Physical and biochemical activity favoring the storage for a satisfactory period. But now everything is perfect. Science and stored process continue to release mostly minimally depending on the variety of the storage products. The researchers and the review work to numerical modeling or foresight pre-calling of fruits and vegetables demonstrated that the rapid cooling system is applicable to reduce the foil temperature of various shell products such as fruits and vegetables. We reused it was necessary to have input variables. Firstly, the speed of cooling air, the cooling temperature in the tunnel, and as output variable in time used to achieve to programming temperature and the product presentation format of the product to current or pre-cooling or rapid cooling are the type of contained and packaged, in which they calculate the performance effectiveness of the system and time they present the model and simulation, the descriptions of different methods and rapid cooling of fruit and vegetables. They are showing the person and need to remove it from products quality favored the logic conservation of side product. Objectives in this research for work, the following objectives were raised: modeling of the rapid cooling, system simulation of the rapid cooling process in perishables products, and temperature control in the rapid cooling tunnel. There with the use of fuzzy logic and LabVIEW software. When the research for modeling and simulation of combustible in spontaneous fermentation using logic carried by research, he efficient used logic in the laboratory virtual instrumentation engineering work, part in which the obtained results affected with full or graphical programming of the software indicated above, very far from linear programming since it does no use a mathematical model nor the participation of a programming specialist. It is only necessary the participation of a person with experience in relate process. Membership functions for the temperature variables were checked at 2014. To research the rules the cooling process, the tables are constructed where the input variables temperature, cooling speed are presented and the output variables the time minutes used in the cooling process in the table 1. these variables are presented. Results and discussions, and according to authors who posit the use of fuzzy logic specialist specification-based rules in the system, then the specification has defined by mandate allowed me to get the virtual instrumentation of temperature in degrees Celsius using the corresponding sensor as to control the velocity in the system or cooling tunnel in unit sub-meters per seconds. Now, and the output variable was for the time that would delay the cooling of the products in the tunnel of rapid cooling by forced air. To control the cooling time in the rapid cooling tunnel, the Fourier process variables have been take into account input variables such as the temperature of the cooling system and the rapid cooling tunnel that can regulate to low temperature 2 to 4 degrees Celsius. Medium temperature 4 to 6 degrees Celsius and high temperature for cooling and rapid cooling tunnel 6 to 8 degrees Celsius. On the other hand, is the speed of the cooling air, low speed 0.5 to 0.185 meters seconds. Medium speed 0.185 to 1.15 meters second, and high speed and performance variable. It is the cooling time of the perishable products in minutes in a low time 14 to 15 minutes. Medium cooling time 15.5 to 16.5 minutes, and high cooling and the products 16.5 to 18 minutes. In kind the seat fig 2. Rules. At this stage, following second how considered with applied in the cooling process in the forced air rapid cooling tunnel for perishable products. One, if cooling temperature 5 degrees minutes is frozen and cooling temperature 5 degrees is medium and cooling temperature is 5 degrees is hot. 2, if cooling temperature 5 degrees Celsius is medium, then cooling time minutes is medium. And if cooling temperature is 5 is hot, then cooling time is low. And rapid cooling air speed meters seconds is medium, then cooling time minutes is medium. And rapid cooling air speed meters second is high, then cooling time is low. This system, when the cooling temperature is controlled in the rapid cooling tunnel, which is present in figure 4, and test system in which they have the input variables cooling temperature, cooling air velocity in cooling tunnel, and has an output variable. We have to cooling time and the persistent products. When a change is made to the input variables, we will automatically have a new in response and the system output. Program in the block diagram of the livable software virtual instruments have we installed, such as the thermometer for reading in degrees Celsius and the air velocity meter for reading in the meters per second, which are considered as the input variables in the system or tunnel, happy calling by forced air, and now as an output variable, the virtual instruments was installed to measure their time and takes for the products to reach the program temperature for reading in minutes values in the cooling of the products in process, which is appreciated in figure 5. In the block diagram of the livable software, the fuzzy logic was programming with the input variables. The virtual instrumentation is presented with the installation of the thermometers, the sensor for measures, the cooling speed in the tunnel, and the result of outputs values and the time measuring instruments used in the cooling of the personalized product. Simulation. In the simulation, it will necessary to use the modeling program, simulation and cooling temperatures control in a forced air rapid cooling tunnel, and according to the program is fuzzy logic, in which we learn by introduce the cooling temperatures values that are request the speed of the cooling in the tunnel, which is considered as the input variables in the system and the output variable. The time used to reach the program temperature, this can be in the table 2. Air speed and temperature. To 0.5 air speed, temperature 5 degrees Celsius, and time is 17, time height, and to air speed 1.5, and temperature 5. Tempo cooling is 15. Log time. Simulation. Conclusion: modeling, simulation, and temperature control have been carried out in the rapid cooling tunnel for personalized products. Using logic, different variables can be simulated in the rapid cooling tunnel. 3 for more different cooling temperature, various different cooling air velocities in the cooling tunnel. Cooling for removing fuel head from perishable products in the shortest possible time. For low values of rapid cooling temperature in the tunnel and else low speeds, the cooling time is high. On the contrary, when the temperature is higher and the air speed is higher, then the cooling time is short. Using logic, the modeling, simulation, and temperature control in the rapid cooling tunnel system for peristaltic products was facilitated since a graphical and monolinear program is used. It is used in industrial and in process laboratories. Thank you very much.
Thank you, sir. Will the chairs like
Thank
to
you.
ask any question?
Yes, one question from my. Your presentation was very good. Even the topic which you have selected is very good. You have not mentioned any references in your presentation. So, how many publications you have just done for the literature review?
Now student electricity is consumed.
Yeah, actually, regarding
Now,
your topic, how many papers you have just read out?
please
Yes,
repeat,
I'm
please.
just asking how many number of publications you have read for this paper? You have
Now,
not mentioned any references.
now remember.
There must be some literature review. So you have not even shown any literature review of your topic. Have you studied something about the previous work on the same topic?
Yes, I work and others work.
No, actually, I'm not getting. So you have not mentioned any references. How many references you are having in your paper? Have you studied all the papers? Or just tell me the number?
Uh, yes, others authors, it is recommended or used software lab review.
Okay, actually, I think you are not getting my question. It's okay. It's okay. Okay. Anything else?
Thank you.
Okay. Most welcome. Okay. We can move with the next presentation.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to once again ask for Rafian Ramadhani with the paper titled Digital Transformation of MSMEs in Mutang Village, implementing the RSM utility design for enhanced market access and operational efficiency. Sir, if you're here, then you may start with the presentation.
Can hear my son?
Yes, yes, sir. Please go ahead.
Okay. Yes. My presentation is show.
Yes, sir. Please go
Oh,
ahead.
okay. Okay. Yes. In this session, I will presentation about my research paper about digital transformation of MSMEs in Muntang Village, implementing the RSM utility design for enhanced market access and operational efficiently. With me, Rafina Madani. The first is background is about a role MSMEs in Muntang Village. Micro, small, and medium enterprise MSMEs are crucial component of the local economic structure in Muntang Village, Pemangkon Sub-District, and Purbalingga Regency. Which means is MSMEs is uh main 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 money for a villager in Muntang Village. And second, challenges faced by MSMEs, limited access to broader market and lack digital visibility in MSMEs in Muntang Village. Also, many MSMEs in Muntang Village, but it's not show to public or about digital. And the third important of digitalization, the first digitalization is essential for the survival and growth of MSMEs. And the second, the digital are demands strong market penetration and business competitiveness. And then next in our research objective, we want to develop a catalog to design and develop digital catalog application that showcase various MSMEs in Muntang Village. Many MSMEs in Muntang Village, and we will unity in one application is Wismin Catalog. And the second is access. This application aims to facilitate user access to information about product and service and about MSMEs in Muntang Village to offered by local MSMEs. And a benefit for digital catalog application was enables the first enables MSMEs to reach a broader market, and the second is awareness and enhance brand awareness in the public eye. And next, the research methodology. The first adopt a simplified design methodology using LSM, recognize, scrutinize, and materialize approach. And the second is approach ensures the application meet functional, aesthetic, and practical needs for user. The first step is recognize the information collection and user identification. We do interview with villagers and Muntang village. And the second is scrutinize. We need we do need analysis and user interface design to the to next develop is application and prototyping in materialization. And the last step is testing and iteration to from feedback from feedback from villagers at Muntang village. And this design about homepage in website in web interface. And this design about product gallery in web interface. And next is design about product gallery in mobile interface. This user can customer or user can order use this application and move to simply step with WhatsApp via WhatsApp. And the conclusion is implementation about MSM utility principle in New York. MSME's catalog application involves several strategy layers, which means layer R is this application is customized to align with the shared values and preference of the village community. And the second, emphasize collaboration about MSMEs and foster open innovation. Layer S ensures the application is accessible on variety devices commonly used within the village. It means is web page using a laptop or using a handphone and using a smartphone, sorry. And the second, improve the rich usability of the application. And the third, layer M is integrate learning feature, the aid user understanding how to effectively utilize the application. And second, implement user-friendly rules to facilitate the management of UMKM operation. And next, additionally, to ensure application maximally implement and training mentoring session are conduct regularly every week, helping to maximize the application usage by impact. By adhering to this structural step, the application is tailored not only meet the specified needs of the village community, but also boost the local economy by leveraging digital technology. Thank you for my session. Okay, my presentation is end. Sorry, Miss Moderator.
Thank you, sir. Ma'am, would you like to ask any question?
People I reach in this interview about this application is around 20, which means is a sample in application to, which means is you MSM is actor or applies in this research 20,
Okay.
around 20.
Okay, what is the new point which you are going to uh, consider in your research, which is not already been implemented by the previous research?
Okay, previous research, yes.
Yes. What is the difference? Actually, you are just saying that your research is better. So, in which words, how you can say that? Because you have already read the 20 papers. So, which technique they have used, and what is the new feature you have just applied in your research?
Okay, I get the point. The difference is with the old research is we implementing in new village, which mean not rich for the technology, is new for the villager at Muntang village. Is the first is the method is when use the methodologies is the first used in the village context, and which means is developed before apply in village context is focus in educational technology and other, but is new in the methodology is new to implement in village context about MSMEs. As that is different or improve from my research compared by old research.
Okay, thank you. No more question.
Okay.
Thank you, ma'am. Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Gurdal Irtak with the paper titled Novel Insights into Food Ingredients and Additives with Food Analytics, a case study analysis of European packaged foods with pulse ingredients. So you may start with the presentation.
Sure. Thank you so much for organizing. Let me see. Well, okay. There. How can I share the whole screen? 1 minute, please. Okay, I'll just share this one. It's okay. All right. All right. Can everybody see right now?
Yeah, so it's loading currently. Yeah, it's visible. Please go ahead.
All right. Let me also start the timer right here. All right. Thank you for organizing. Thank you for the introduction. And thank you all for being here again today in my second presentation of the session. So this time again, we are applying data analytics. Okay, specifically food analytics, because we're applying data analytics to analyzing food contents. So it can be called food analytics, and this is a term that exists. So how can we obtain some new type of insights, some new understanding using food analytics? And what we will be specifically analyzing is the food ingredients and additives. Okay, so how can we use food analytics? I mean, data analytics basically applied to analysis of foods. How can we apply food analytics to obtain new type of insights about food ingredients and additives? So this is actually a case study. Now, this case study is specifically focusing on European packaged foods with pulse ingredients. Pulse ingredients are like, the ingredients that have such as chickpeas, the legumes, basically legumes. And I think it also includes nuts as well, as far as I remember. But in any case, pulse ingredients is a certain type of ingredient. And we had access to a data from Europe, basically. And we took that data, we analyzed that data. Actually, we spent a lot of time cleaning and enriching that data. And then after that, we gained some really interesting insights that we didn't encounter in the earlier literature. These types of specific insights for this type of foods. So, and the methodology that we apply here for the food analytics methodology we apply here can also be applied to other types of foods or other categories of foods, because the methodology is quite general. And it's a very important health concern these days, these ingredients, and especially these additives, the ones that start with E. It's a major health concern, and actually it's also a personal concern of mine, and also my colleague Dr. Natalia. We are really interested in creating good food, eating good food, our health consciousness. But then let's do a scientific study, data analytics study about it. So that was the research motivation. And this is again a research with 4 of our undergraduate students and another 4 brilliant students at the undergraduate level. They now graduated, and this was also their senior project. One thing that we are trying to do at United Arab Emirates University in our college, in our department, is to really push our students very, very hard and really, challenge them. Of course, also in the meantime, support them so that they create a very high quality research output at the undergraduate level. So again, the research question is, how can the integration of descriptive data analytics techniques be utilized to analyze and benchmark ingredients and European Union coded additives in European packaged foods with pulse ingredients? That's a research question. Okay, so this is the original data that we got. Actually, we got this data from one of those data journals. I think it was the data journal itself. I don't think it was Data in Brief. Anyhow, we got the data from one of those two journals, and this is the original data. Now, as you can see here, column F is actually not so clean. I mean, it's in a different format. It's in a JSON format, basically. So we had to do a lot of cleaning, a lot of data cleaning, and we even used ChatGPT to do some of the data cleaning. And then eventually, okay, so this is the original data, basically. So the data has which market the food is coming from, or which market the food is available at, in which year it was introduced to that to any market, basically, at all. And the last, so these food products, they get new innovations. So there are multiple entries for the same food product. Of course, the food product is the, oh, sorry, this is the row ID. And okay, so, all right. So this is for each row, okay. So each row is a combination of year, market, and product. Anyhow, so since last innovation, how many years has passed? How many years ago it was introduced, and other metrics. Okay, so this was the original data, and our eventual motivation is basically how can we develop some methodologies so that food companies can develop healthier food products, and also maybe even the governments can also understand how they benchmark with other countries, and maybe they will also target more healthy food products. So when we look at our research, we obtained some domain knowledge. We are not experts, we are not food experts, but we got some domain knowledge through literature review. And then we obtained the data from a data journal. Now, it's a very big secret that I'd like to share with you all. If you get data from these data journals, it's a verified data and it's already published. So it's very easy if you publish, if you analyze it, you can easily publish on top of those data, but it has to be a recent data. So it removes many of the data validity issues. So we analyzed this data through this case study, and it's now ready. We have some ready results that could be used by the food industry. Now, this is the augmented data set. Augmented data set, oh, sorry, this is the original data set. Then we augmented this data set later on. 1 minute, please. Yeah, this is the augmented data set. Sorry, this is the augmented data set. As you can see, for each product, now we have how many markets it's offered in, how many ingredients. Okay, all right. Can you hear me right now?
Yes,
It's
sir.
okay now? Can everybody hear me? Okay.
Yes, sir, you're audible.
Okay, sure. Okay, so let's continue. All right, so that's the augmented data. So the first result, which countries have food products? Again, these are all packaged food products with pulse ingredients. So it's not all the food products. It's not all the food products in the market, only that segment, okay? So immediately we can see when we look at the average number of ingredients, average number of additives, and the proportion of additives, when we look at these three, some countries are consistently doing good. For example, Italy and Slovenia, they have really small numbers, especially they have very few number of ingredients and they have very few number of additives on the average. Another good country with regards to that is Sweden. Sweden also has healthier products in the market. And if you look at the proportions of additives, of course, also we could look into Estonia. Estonia, even though their products are a bit sophisticated with a lot of ingredients, the number of additives is really small. So that's another pattern. So these are the types of patterns. Again, of course, none of us is going to remember about the country results, but these are the type of analysis that could be done. So when we look at the number of ingredients, okay, so we can see Ireland is the worst because it has the darkest color. We plotted this using R, by the way, our programming language, our statistical language. And then we also look at the standard deviation of ingredients. So we see that, for example, Italy has few ingredients, also low standard deviation, which means there's not much variability. Pretty much all the products, well, not all, but most of the products there have few ingredients. Okay, and similar picture with additives. Okay, so Italy has food products with few additives. Okay, and then the standard deviation is also low. Okay, so right, and on the other hand, Hungary, for example, is not doing well. It has many ingredients, many additives, and also a lot of standard deviations also very high. So there are even some food products with too many additives. Okay, so I have 1 minute left, so I will just really do a really fast summary. So which ingredients appear in most products? We saw that this additive, basically, this is an EU coded additive, and this additive are appearing in many products. Okay, and water and sugar are appearing, and of course these are the preservatives probably that are used the most. And so you can see which additives are the most used ones. So if you want to avoid those, you can also work on that, develop some manufacturing processes so that you could still produce the food without those ingredients. So you could also do analysis on a country basis. So this was the whole European Union market, whereas here you can see only a single country such as Austria. Okay, I think there's a chat message. Okay, sorry. Okay. All right. So then another thing that we did was, okay, which countries seem to have similar patterns when we look at these different metrics that we developed? Which countries are appearing similar to each other? Which countries' products are similar to each other? And Germany, Ireland, UK, when we say UK, this is UK and Northern Ireland combined. Okay, so these countries, they are really different than the rest of the countries. But here we have a group of countries that are quite similar. So let's zoom over here. So we can see that the product profiles, not the specific products necessarily, but the product profiles are quite similar, especially in these countries. Okay, so if you see them connected, it means they are very similar. The market, the number of ingredients, number of additives, okay, the type of additives, the type of ingredients, they are very similar in the countries that are connected, especially Finland and Sweden. Okay, and also even these countries, they are somewhat similar. Okay, and when we look at the number of markets, okay, so here we can see that the food items in Italy, okay, it's very light color, which means in Italy, the food items that you see, they don't exist in too many markets. They exist in very few markets, Italy being one of them. So it has to be at least one anyways. So it means it's a very low value. Whereas when you look at Lithuania, the food products in Lithuania on the shelves, again, these are packaged food products with pulse ingredients only, right? So these are having many appearing in many markets for Lithuania. Okay, so which means whatever you are seeing in Lithuania, you can see it in many more markets and probably many imported items as well. Okay, so basically the countries which have light color here, they are basically selling or have in their market food products that are available in less number of markets. Okay, so that was the end of my presentation. This is my personal website if you'd like to learn more about me. And this is my organization, and of course our organization. We are all from the same university. This is the city of Al Ain, and this is a castle that you are seeing. We are from the United Arab Emirates University, and these are some other photos from other parts of UAE. And yeah, I'm an associate professor there. I'm specifically working in data analytics. But my PhD is from industrial engineering from Georgia Tech, and I served in multiple different countries. I work on data and business analytics at most. I'm also into blockchain, supply chain management, project management, R&D management. And thank you so much. There is a very standard question. I want to answer that one immediately. How many research papers we read? Many. The answer is many. So we have in the main paper, we have around 20 references, and I think around 10 to 15 of them are related research. And in the supplement, we have another 20 references. So we have read around, we read more, but we cited around I would say 20 to 30 papers related to food analytics and our domain. Okay, thank you so much. I just want to answer that immediately. I don't know if you can see, we have actually a supplement is 16 pages, so we were kind of limited with the paper itself. The paper was only allowed to be 10 pages, I guess, right? But then the supplement is 16 pages. So, it was a very extensive study, I would say. Thank you so much. That's all from my end. Yeah, any questions?
Yes, nice presentation. Actually, I am literally very happy because by the previous author, I have asked two questions and you have already answered the question, that question. I think I might be thinking that the same question should be put in front of you. Yeah, you have already given the answer of that question. So I'm
Thank you,
already
Dr.
satisfied with your
Mamoria. Thank you so
presentation.
much.
Okay, okay. We can move with the next presentation.
All the best. Thank you so much.
Okay, most welcome.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Hector Rafael Murano Okono with the paper titled Probing Artificial Intelligence Applied to Topology Optimization for the Generation of a Chassis of an ATV. Sir, if you're here, then you may start with your presentation.
Yes, sure. Let me share my screen. Okay. Okay, so let's start. Hello, everyone. I'm Hector Morano. I work for Technological in Monterrey, campus state of Mexico. The title of this presentation is Proving Artificial Intelligence Applied to Topology Optimization for the Generation of an ATV. So this is the agenda I'm going to follow. First, I will give a brief background just to put you in context. Then I will mention the objectives of this work. And subsequently, I will describe the methodology that we used. Finally, I will share the conclusions and future work. As mechanical engineers, we want to explore artificial intelligence through topology optimization. These artificial intelligence algorithms allow us to design tooling, machinery, casing, household appliance, and automobile components, just to name a few. But thanks to artificial intelligence, anyone can now use topology optimization. So the objectives of this work were to explore the use of artificial intelligence applied to topology optimization using a software application to generate the chassis of an ATV. And the second one was to identify the results that can be obtained from the software application. So now I will describe the methodology and its main components. Let's start with the definition of the framework. So this work was done for a semester mechanical engineering students during the machine design course. 26 students participated in the 2021. The software that we used was Fusion 360 because it has academic versions. All of them are free for students and educational institutions. So students can install them on their personal computers. Another advantage is that the analysis that are performed in the cloud, so we can see or we can get the files from any computer. The computational resources employed were computers with an Intel Xeon CPU processor at 2.8 gigahertz with 16 gigabytes of RAM. So now this is the case study. It concerned the design of the chassis of an ATV that should withstand lateral, front, and rear forces of 75,000 newtons. The case study was selected because it allows evaluation of different stages of the chassis design. For example, Initially, it is required to specify its design restrictions. Then we can use topology optimization, and subsequently, it permits evaluating the results, and the results can be verified by employing finite element analysis. So here we have the initial conditions for the case study and the material properties for the case study. So for example, in table 2, we have the general properties of the steel that we use, the density, Young's models, all the mechanical properties. And in table 1, we have the initial conditions that we use. For example, first we have to define the material. Then we have to activate the gravity in Z axis. Then we have to specify perpendicular forces to the different faces. And we fix the base. We use just a plane of symmetry. And the boundary condition that we used was less than or equal mass reduction percentage of 50%. And we wanted to maximize the stiffness of that geometry. So here we have the topology optimization results. The first result is the percentage of mass reduction with a chassis design proposal. The first proposal indicates a 50.9% mass reduction, equivalent to 1,668.4 kilograms that was obtained. The intense red regions are the surface that must be preserved to resist the forces of 75,000 newtons. As the intensity of the colors decreases to green, it indicates that they can be slightly reduced to further decrease the chassis weight. The surface where the 75,000 newtons are applied are preserved as they present the regions that support the loads and cannot be removed. The second result is a mesh representing the location of the bars that will create the ATV chassis structure. This can be 3D printed or converted to solid geometry. To verify that generated chassis support the forces of 75,000 Newton, it is necessary to convert the mesh to solid with extrusions and cutting operations. Now, a static analysis of finite element is performed to calculate the stresses of bond misses. The boundary conditions are fixing the base and placing the forces of 75,000 Newton on the initially specified surface over here. The maximum stress is 69.6 megapascals. From the previous table number 2, the yield strength is 207 megapascal. So the chassis resists the forces of the maximum stress. Subsequently, the chassis can be replaced by standard tubular sections to manufacture with commercial profiles. In the static analysis, the joints of the profiles can be considered using welding or some other mechanical fastening method. Here we can see an example of what the chassis would look like with tubular profiles with a diameter of 1.5 inches. So here we have the conclusions and future work. The initial conditions that must be specified to obtain the chassis design through topology optimizations are the material to be used, the direction of the acceleration of gravity, the identification of the symmetry planes, the definition of the load, the specification of the boundary conditions, and indicate if it is required to maximize the stiffness of the component or the percentage of mass reduction. All these initial conditions are sufficient to generate an adequate result. The generate mesh representing the ATV chassis can be easily replaced by circular profiles This allows for a real design of the chassis structure. And thanks to the Fusion 360 software application containing the programmed artificial intelligence algorithms, users can quickly generate the component design through topology optimization. They only have to specify the initial conditions of the design through different menus and dialog boxes without having to program some routine and perform calculations with artificial intelligent algorithms. For future work, the chassis design should use standard circular shapes, which would allow it to be adapted to commercial profiles. And finally, calculating the total length of circular profiles required to manufacture the ATV chassis is also recommended. For the finite element analysis, it is advisable to represent the joining method between the different tubular sections, probably through welding or some other mechanical fastening method. So thank you very much for your attention. If there are some questions, I'll be glad to answer them. Thank you.
Question?
Yeah. No, it was very nice presentation. There is no question from my side.
Thank you very much.
Okay, we can move with next presentation.
Thank you, ma'am. We have a presenter from the previous session who was not able to present their presentation. We'll be taking him up next. Dr. Abdul Wahab Samad, you may start with your presentation, sir. Dr. Abdul? It seems he's not here. We'll be proceeding with the ending of the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version on all the previous 7 versions of the conference. We'll be happy to have you in the 9th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of WS4. I'd also like to thank our session chairs, Professor M. Shamim Kaiser, for chairing this session, a token of appreciation to the chair on behalf of Team WS4 and Global Knowledge Research Foundation. I'd also like to thank our session chair, Ma'am Meenakshi Memoria, a token of appreciation to the chair on behalf of Team WS4 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Okay, thank you.
Before we end the session, I kindly request everyone to switch on the cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
You too. Thank you. Bye-bye.
Thank you. Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.